Welcome to the Human Factors and Ergonomics Hub, a series of educational podcasts that showcase the connection between human capabilities and good work design, brought to you by the Human Factors and Ergonomics Society of Australia.
Hi, I'm Sharon Todd and I'm back on the HFE Hub after a short mid-year break. I'm very excited today to be chatting to Donna Duffy, who is a human factors engineering specialist with over 25 years experience in human factors and psychology. She's the founding co-director of Human Engineered, and she brings deep expertise to industry, including defence and aviation, where she drives organisational change and system design excellence. Look, Donna, it's an absolute pleasure to have you on the podcast today, and thank you so much for joining me. You have a really interesting background, defence and aviation. Maybe you could tell us a little bit about how you became interested in human factors and ergonomics.
I guess I've tried to think about this in a quick way, which it's a bit of a long path, so thank you for asking me, and thanks for having me. My early career was a bit mixed and I wanted to work with children, so this is a very weird path. So I did that and eventually completed a psychology degree. When I received the degree, actually even before, I worked with adults with mental health diagnoses, like doing assessment and treatment, and later with people who had physical and intellectual impairments, never children in that space. So that was a bit strange. I think my career took lots of twists and turns and I finally found human factors. So my husband, Peter, was an engineer in the Navy, which meant we moved around a lot around Australia and I got to see lots of different things, lots of ships. And eventually his career took me to, or took him really, to working on the Sea King helicopter at Nowra. And while I was there, I started in a Masters in Human Factors with University of Queensland. And there I met Penny Sanderson and Andrew Neil, and I ended up working there more recently with them at Boeing Defence Australia. But and you just realise how it's such a small world and such a small industry. So this degree kind of and then working in that environment led me doing a thesis in maintenance era. And from there, I was just really keen to find my first HF role. So my first 25 years, I was thinking about that today, was on a bit of a quest to improve how systems work and making sure the design improves life for people. People often say stuff to me like, but the first bit wasn't human factors. You can't count it. But I include it because it's helped me shape my learning and experience, and particularly helping me to understand how people behave, learn and work within their environments. But cognitive ergonomics is my favourite space to work and I really love doing that. So that's kind of me and how I got to where I was.
So what are you doing at the moment?
At the moment, I'm currently just working as a co-founder and director at Human Engineered. So I left Boeing and I work in a consulting capacity as a principal HF specialist. Right now, my role is building our business and working with two other amazing directors who I think you know, Nick Pearsall and Brooke Dench. And our time's been split with completing client projects and advancing our internal. We've got some R&D happening with a human factors tool set, a couple of different things going on. We just finished up a project where we were working with a company called Coherix, and we completed a project on developing a cognitive modelling prototype with Defence Science and Research Group. So,
do you want to have a chat about that? Cognitive modelling?
Oh, yes. Can't really... it was a lot of fun and I got to work with awesome people. So Sandra Lambert and Peter Blanchett. Anyway, they're really cool, and working with great people is always important to me. The cognitive modelling part, so one of the projects that I was going to talk to you a little bit about later was MQ28, the Loyal Wingman program, so really high level. But I thought that's kind of the most interesting thing I've done. And they're looking at things like human-machine teaming, so one human with many aircraft, which is so we're looking at how humans can cope with all the multiple things that they need to do in that environment. But how do we design a system that improves human performance, or doesn't impact on human performance? The work that we're doing that we did is around getting objective data, rather than getting a lot of the work that I've done previously is around getting workload data through NASA TLX, all that kind of stuff, feedback from users and stuff like that. But we can actually do some work with a tool which is called ACTAR, and Nick has actually been doing lots of the programming side of that. So that's probably all I can say, but it's about how it's using an objective data modelling tool to help develop requirements and interface and stuff like that for all different types of projects, actually.
What was I realise obviously you can't talk about this project in its entirety, I imagine, but firstly, are we talking about the MQ-28? Is that what you said was a project you were going to talk about? Or
Oh, yes, that's the project I'm going to talk about, but this project we just worked on with the cognitive modelling was just around one-to-many teaming, so it could be any human with many aircraft.
Human-machine teaming. Okay, it's not a phrase that I use in my own work. So I'm just focusing there for a second. What is that exactly?
So it could be. So there's lots of different ways that people not explain it, but there's different terminology for it. So it could be human autonomy teaming, human machine teaming. So it's just about one human looking after multiple systems. So it could be robots, human looking after multiple autonomous robots, aircraft, ground vehicles. It could be lots of different things. So they might be partially autonomous, so that human might be on the loop, doing stuff, monitoring and all of that kind of stuff, and the system may call on the human, fire an alert or something like that, to bring the human back in to take over when something's complex, or it just depends on the system really, or it could be full autonomy. Yeah.
So obviously you've come out of Boeing previously and would have worked on some fairly amazing projects, and I think the MQ-28 project is something that you wanted to talk about. You referred to it as the MQ-28 Ghost Bat. Maybe you could tell us what that is.
Yeah, sure. So I guess I worked on a program that was called MQ-28 Ghost Bat System, and that's the design example that I was going to go into, but I can't really talk specifics, but I can talk everything at a high level. If you can Google it, I can talk it. So the aim of the work that I was doing early in the project was to support the design of the aircraft. So there are different elements to the system. So there's an aircraft, a ground control station where the operator or the pilot sits and does their work, monitoring the aircraft. A lot of questions I got around that at the beginning was, why does anyone care about human factors if no one's going to be in it, for the aircraft? Which, I've got that question a fair bit. But the aircraft, it's an advanced unmanned aerial vehicle, so UAV, which has been developed and built by Boeing in Australia. So a lot of information on LinkedIn and stuff like that you might see talks about, it's Australia's first aircraft built in many, many years. But they're doing it in collaboration with the Royal Australian Air Force. And the primary aim of the aircraft is for it to serve as a loyal wingman, which augments the capabilities of crewed aircraft. So it could be like a fighter jet, like the person operating or flying with the unmanned aircraft is in a crewed aircraft. Sorry. So the idea is to advance the overall effectiveness of air combat operations. So
this is so that an unmanned vehicle can go where a manned vehicle can't.
Yes, exactly. So they extend the reach and capability of other platforms, and so that the pilots aren't exposed to additional risk.
Yeah.
Yes.
Okay. So the feedback you got was, why bother worrying about what the pilot's doing if there's no one in it? So tell me about that, because it has to be controlled by someone. So imagine you're looking at the interface between the person controlling it and...
Yeah. So I guess there's different aspects. So we'd look at all the different system users, and initially my focus was on supporting the design of the actual aircraft, and there's nobody in it, so there's no need to worry about the passengers or the pilots, whatever. But we needed to be focused on how the maintainer would, maintain the system. There's control panels on it that need to be operated by a human. So although it's autonomous, it's important to design it to be suitable for whoever's interacting with it. The ground control station, so I guess there's elements of that as well. Some other companies was designing the interface for that, but so my role was to understand how the pilots were interacting with it and then provide, feedback and design recommendations and things like that. So the pilot needs to fly the aircraft beyond visual line of sight. So if you think about the different types of way drones are flown, like some can use a joystick, and using a joystick, pushing the joystick forward, aircraft goes forward, and that kind of, it's kind of intuitive in design. But there's a lot of things that you need to consider just for the interface. So what needs to be in their critical line of sight, what's the most important things they need to see quickly, all of that kind of thing. But apart from just the interface, the GUI design, there's, workstation, how do they sit, the physical ergonomics around all of that. Things like glare in this, I don't know another word for it, except they used to call it a donger. So they're sitting in a, like a thing that is like a facility.
Like a bubble?
They work from, like this bubble on it, yep. And, things like glare and stuff like that. So, because it was a prototyping exercise, it's things for glare, I'm doing stuff like taping cardboard onto the windows to stop the glare, I guess it's all the things that we do that, trial and error stuff in prototyping phase, but very fast-paced and lots of different methods and things like that we had to use to just get the first stage happening.
Cool. So the mocking up of this, obviously, we've laughed previously about some of the mock-ups that we've all done with cardboard and things, but they're brilliant. And then glare is a huge problem in transport generally. So I guess my big question is, whilst in the mock-up phase you were using cardboard, did you actually come up with a solution for their, are we talking like a retractable shade of some description? What did you come up with?
They actually moved the facility, so it was a short-term temporary thing to do some initial testing on the base, and then they built a permanent facility with all of that in mind, which was actually great. So I think they put in some temporary blinds and stuff like that, but it was just to kind of show them that it was, necessary. I think the project people were thinking more about the aircraft and the system and, not the people. So,
yes. Yeah. And then your design was also looking at, were you doing the interface, or was that the third party that was doing the interface?
Oh, third party was doing the interface, but we were providing, I guess, prototypes for little pieces of it's hard to explain, but I guess little pieces of the interface, like plugins, I guess, for things that, things that needed to be added in to support.
Okay, so these are really interesting projects, and you mentioned obviously NASA TLX that you previously used. What kind of tools do you use when you're doing this kind of work? Is there a particular, there's lots of different tools and they're all different. Do you have something that you really like, or?
Oh, well, I guess, so for this program, someone was actually asking me this the other day, what software tools do you use in human factors? How do you do your work? Well, I use a spreadsheet for my hierarchical task analysis. It's very technical, but so I still use that. I put it, in diagrammatic format if I need to, but they're usually big and you can't really do that with these. So, and I usually put a lot of things together. So I might be doing a HTA with some workload data that might go in there, or, what's the potential for error on each line, like a Sherpa, but putting it all in the one thing. And then we could work with the training team who will look at each line and what training needs to happen for each of those things. But for the task analysis, we did some work around this to support the design of the aircraft before it was built. We did that in virtual reality. So I think a lot of that was done, with an SME walking around the outside of the virtual reality aircraft, doing a pre-flight checklist. So we kind of worked through that, looked at timings and all of that kind of stuff, which then fed into some requirements. And things like you were able to go, can you fit your hand through that hole? Like, it was a very basic outline of the aircraft. It wasn't, you couldn't move things or anything like that in virtual reality, but you could put your hand through a hole and see if that would fit, and what difficulties you'd encounter with different elements of maintenance. So I found that really useful. It's not something that we'd normally had done before. Usually it's, I don't know, in air traffic control, we'd built a console and out of wood and, stuff like that to test things and to make sure that it was okay before going ahead and cutting metal on the real one. But this I found really useful, and you could identify where some risks were and design them out pretty early on, which was great.
And so is this the first time you've used virtual reality in design?
That was a few years ago now, though. That's probably 2019, 2018 that I did that. But, yeah, since then we've actually developed some other things which have been really cool and fun to use. So cool and fun, but also good.
Can you talk about any of the cool and fun things?
Yeah. It's probably – so it's like the cognitive modelling that we've been working on, but it was much easier to design tools for physical ergonomics. We could put some things in virtual reality or augmented reality, which, there's some different tools. But you can see it, like you could see things from a first-person perspective or a third person. So it was really good for, designing a console. You could sit someone at a console. You could look at reach. You can put standards in it. Like different 5th and 95th percentile users. You could make the person be the model in the thing be the 5th percentile. You could be it yourself. Like you could be the 95th and feel what it would not feel, but sense what it would feel like from their perspective. Anyway, so there's been some pretty cool things that have been developed that I think are useful, and I guess the reason for developing them was seeing things that kept getting built or purchased that didn't suit the user or the work that they had to do within that environment, and seeing people, raising risks and seeing this. And this has just happened across my whole career, nowhere specific. But and I guess everyone I've spoken to, I think, feels the same, is that, you can raise risks, you can say that these things are going to happen, you need to change the design, but eventually someone in a project is going to accept a risk. You can design as much out as you can, but at some point someone's going to accept the risk and the project's due to complete. I don't think I've ever seen anything go across perfectly into operation, but I just feel like being able to do those kind of assessments really early on gets good buy-in with the customer and, the project team. Yeah, so I think I really like using that tool.
How, and I'm not sure who was in the virtual reality scenarios. Were they pilots or? No,
not pilots. We hadn't done those yet. There was probably maintainers, and we developed the tool. The tool we developed was at Boeing originally. Since then, our company's developed other ones, but the tool that we used at Boeing was for maintainers, for Well, you could actually put any environment in the virtual reality, and then the person can be any person, any system user.
So I imagine you would have used lots of different people, as you said, different sizes, shapes, backgrounds, and and they have to obviously get used to the environment to start with, because it's a different environment, that VR or augmented reality environment. And and then after a while, you get quite focused, don't you? And you kind of forget that you're in what feels like a parallel universe.
Yes.
Yeah, and you suddenly, it's quite mindful almost. You become quite psyched to think about the actual thing that you're doing in itself. There would have been some interesting observations through that, I would have imagined.
Yeah, well, we weren't really using it for training or anything for long periods. It was probably more just getting in to have and we'd make sure people were sitting down and stuff like that. But it wasn't extended period, so we didn't have that, simulation sickness issues or anything like that, because they weren't in it for long enough. Yeah.
Are these static environments that you were? Is it a static environment that you're designing in the VR space, or is this within an aircraft or of some sort? In which case, you've got some other things happening.
We started with a static environment, so it's just an aircraft. You can walk around in it. You can sit you can sit virtually in a chair, or things like that. But the thing that we were trying to do was alter the design on the fly. So if there was something like a screen that we wanted to add in, we could add it in, measure the human up really quickly, move it, so that we could actually get a quick, do a quick assessment and get a quick answer and move it around.
And so did you achieve what you planned to achieve from that project?
Yeah, we did. So that was a separate innovation project that I was, myself and Nick were doing at Boeing, actually. And we did achieve it. The US took it on board, and they've continued to develop it since we've left. So that's really cool. We had separate funding and everything for that. And I think it was really nice that a human factors project got separate funding. Like, feels pretty unusual. But I was pretty happy with that.
Could you tell me about some other projects, or another project that you've been working on that uses different tools or looks a bit different to the last?
So a lot of the ones that I did work on were obviously aviation related. They're the most recent. Probably my last 15 years has been aviation. So I did work in air traffic control for a little while, many years ago, but it was still developing consoles and GUI interfaces and things like that. I did another project that I worked on was called a Helicopter Aircrew Training System. So that involved the live training environment, which was a helicopter, simulators like flight sims, desktop trainers. There was a aircraft replica trainer, which was like a helicopter right up on 5 meters high above on a platform. So you would learn. So it wasn't just for pilots. Pilots would learn to fly, but there were also helicopter aircrew that were in the back of the helicopter. They were in an EC-135, which was an Airbus, little tiny helicopter. And they were wearing these big Army and Navy outfits with their helmets and NVDs and like big people trying to maneuver in the back of this helicopter. So I don't have to tell you what that would be like for people. Crowded, yeah. So I guess a lot of the stuff that I did in that program was around physical ergonomics, making sure that people were able to sit in the seats in the back of the helicopter and the pilots, but that was all designed, that was already designed and would have been assessed by Airbus human factors people. And so that was well designed. So, but putting people in the back of a helicopter to do training on, standing with the door open, standing at the edge and all of that kind of stuff that they need to do for their training, that was a lot of different types of work. So I would be looking at seats, how they maneuver around the helicopter in the back, but also how they would egress in an emergency. there was another part of the project which had a Hewitt kit. So that had to be a frame. It was designed as a frame similar to the helicopter, very similar, but it would get submerged in water. So people would have to learn how to swim out of this helicopter using the handles and everything that was exactly the same as the helicopter. So that was a really interesting project. And even things like, putting that helicopter frame up on a 5-metre platform, the design of how you deal with that when they're having to learn to, do the tasks that they needed to do on the edge, looking with the door open 5 metres above the ground, with all the safety precautions in place. And they were also harnessed in, don't want to freak anyone out, but they were harnessed to the frame. But just, the cues and everything are different. There's no spinning rotor and all that kind of stuff that would make the air and the movement of the helicopter be obvious that you're up really high. I guess that was one of my big issues that I kept raising. But so we put all these things in place and to alert when the doors open, there was some cues for the people to make sure that they were aware of, and just all stuff like that.
Yeah, that's actually an interesting point, because you've got the movement of the vehicle and any tilt of the vehicle and the rush of air, head clearances, keeping your head down and
to hang on.
Yeah, I don't think that would be a problem. I think I'd have more trouble letting go. Yeah. Are they in that particular project, were they actually going to leave the aircraft, or is the idea that they're doing something out the door?
So they could be dropping, using a winch to tether to put stuff down onto the ground, or people, or I guess it was teaching them all those things before they actually went on to other defence, specific helicopters, which this was their initial training in a helicopter.
Yeah, I think if you're scared of being 5 metres off the ground, then 500 or whatever, it's going to be a big difference. Okay. Awesome. All right. Did you, in these projects, did you have a go at this yourself? I mean, I realise that you're the designer, but, sometimes experiencing things for yourself is a learning tool. Did you use that?
I didn't know. I'm a bit scared of heights. I'm scared of no. I think that I went on the platform and I experienced that, but I didn't do the dropping down. And no way, Sharon. I'm a bit of a chicken, but I really love that people can do all of this stuff that is it's dangerous. It's it's nothing that I would ever want to do. I like my neat and tidy job, but but I did experience things like the simulator, and I don't know if they were joking when they offered me to swim out of the Hewitt, but there's no way I would have done that.
Did you put that underwater? Because you've talked about having to swim out of it. Did you actually put it underwater?
It goes in this giant pool, and they've got observational areas underneath the pool where you can watch people swimming out. So there's also lots of safety precautions around it and everything. But
so you were just sitting behind the glass watching them. You didn't want to have a go at swimming out, no. And then I guess another factor of the swimming out is its depth in the ocean. So that's a factor in itself, isn't it? So how did you?
I think that they get taught a specific way to do it, and it would be the same on every aircraft. There's a specific egress point. So if you can't get the door off, you can pop. They were practicing, and I observed them practicing popping windows out, and there's a way that you can get out at the front of the helicopter, and but they're I think that the specific trainers train this stuff. They did actually get really nervous as well when some people that have to do the training, they don't like it. Because it's a very, I guess it's an anomaly if something like that actually happens and you're crashing into an ocean and stuff like that. It's not a regular occurrence. So they do their training quite regularly. I'm not sure if it's 1 or 2 years or something like that, but it's been a long time since I did that project. But they actually sit them in a little, I can't explain it. It's like a little rocky thing. They start off doing it in stages. So they don't go straight in and do the diving out. There's lots of different phases to the training. It's pretty interesting, actually.
Of course. And, there's lots of variables, of course, in that, which you couldn't possibly mock up. But, blocked exits and various other things. But so tell me, what have been some of the greatest challenges for you in these projects? What are things that maybe you started at the beginning that you now don't do because you've discovered ways around it?
I think early on, so in the MQ project, I think it was just the fast pace of a prototyping project. It was very different to one that it does have full systems engineering, but it's a bit different. It's iterative, and they'll do something that it doesn't quite work. Let's change it. Do this. So it just happens faster and iteratively. So that was a challenge for me starting off, because I was very structured in how I approached how I did things, making sure that I don't miss something used to freak me out a little bit. The other thing I think is always a challenge is the constant advocacy just for users. Like I think for military people, I feel like, and this is just my opinion, this is not how it is, I just feel like they will always get on and just do the job. They'll get it done, and they want to achieve something, and they'll just do stuff. And I'd be like, don't pick that, that door frame's heavy. You need to see how heavy it is. Don't pick it up. And, just stuff like that. But they'll just do it, and they just get on with it. That is difficult for me. I don't like to see people get injured, and a big part of what I do is based on making sure people are okay. So I came from a psych background, felt like I was helping people all the time. And then I had to find what that looked like in human factors, how does me working with military, but I did, I figured that out. It's still helping people. It's making sure they come home safe to their families. So that's a big part of what I enjoy. Being, if I can help in any way with that, that's what I like to do.
And so what's next for you then?
I'm writing my literature review at the moment for my PhD. It's kind of linked, though, with my one-to-many. We're talking before about the teaming. So I'm doing this thing where I'm exploring, it's called Exploring Human-Robot Interaction as a Collaborative Model for One-to-Many Teaming in Aerospace Environments, so in space. So teaming robots in space. So it's pretty cool, and I'm doing it through the University of Adelaide, and I met my supervisor, Anna Wyatt, while I was at Boeing, and she kept trying to convince me that, I could do this. And so that's what I'm doing at the moment, obviously looking for work because I need to work.
So is the next field of interest for you robotics?
Maybe. It's not something that I was looking at Boeing. I had some work through Boeing. I had some work with them looking at ground vehicles that kind of maneuver through the factory. So I found that really interesting, but that was being looked after by the people in Melbourne, so I didn't really have a lot to do with it. But this has been really interesting. We went to Adelaide and saw the moon, the lunar landscape that they've got made. So there'll be lots of, hopefully we can do some experiments and things like that. And I really want the findings to be relevant to, other work in human factors as well. So I'm trying to make it be practical because, I've spoken to people who are academics about methods and things like that are created that I find difficult to use in practice because they're long and obviously reliable and valid, but hard to use in practice. So I'm hoping that I can do something, create something that I can use in practice.
Is there anything that you want to add in particular that you wanted to say that we didn't talk about that you think is pivotal for someone working in HF?
I think really that we're other people's voices at times, and that people don't know that they can say something, that they can stand up for, there's lots of stuff around psychosocial hazards and stuff like that. Something that I'm passionate about, but I just I guess it just, I feel really passionate that people feel like they have to do stuff in their work environment that can injure them, and they don't feel like they've got a voice to say something about that. I think that we need to remember that sometimes we're the voice of those people.
Thanks for joining us at the Human Factors and Ergonomics Hub, brought to you by the Human Factors and Ergonomics Society of Australia, where human-centred design really matters. If you like this podcast, make us your favourite in your podcast app. We look forward to chatting with you next time.